So we have one last example we're going to work on for today. It is solving trig equations that resemble quadratic equations. So I'm going to write this down. You can do this, don't worry. So we have 2 sine squared theta minus 3 sine theta plus 1 equals 0. What you need to notice is the algebra connection here. Look how this resembles an algebra equation, like instead of sine, you have x squared, for example, minus 3x plus 1 equals 0. Remember, a quadratic equation has to be equal to 0 before you can solve it. How do you solve it? You need to factor it. If you have a quadratic, a squared, you're going to have 2 solutions. Maybe they're both going to be the same. Maybe they're 2 different ones, but you should have 2 solutions. So this would factor into, I'm going to do our reverse operations there. So the first term has to multiply together to be 2x squared. So this is going to be x and x. You do it whatever way you feel comfortable with. And 2 there, so 2 times 1, there's not much other choice besides that, okay? And the last term has to multiply together to be 1, so you're going to have 1 and a 1 here. And they're either going to be both positive or both negative. But the outer plus the inner have to add together to be this middle term here. So I'm guessing that these are both going to be negative. Okay, so first times first, 2x times x equals 2x squared. The outer negative 2x plus the inner minus another x equals this middle term. And the 2 last ones, negative 1 times negative 1 equals positive 1. All right, so I'm going to rewrite that. So in terms of sine instead of x's, because that's really what it is. So what you have here is 2 sine theta minus 1 times sine theta minus 1 equals 0. Well, what would you do with a quadratic? You would set each of these equal to 0 and solve. So that's what we're going to do. We're going to take this one. So we have 2 sine theta minus 1 equals 0. Let's get down as close as we can to that sine theta there. So add 1 to both sides. Okay, so you're going to end up with 2, right? Those go away. 2 sine theta equals 1. And then divide by 2 on both sides. And then you end up with sine theta equals 1/2. Oh, I forgot. I was supposed to give you a restriction up here, so let's just do that. So we're doing, again, 1 rotation, 0. Theta is in between 0 and 2 pi. So 1 time around the positive circle, right? Every positive theta between 0 and 2 pi. So we have one solution here that we have to find all the thetas that work for that. And then we have this other one over here that we have to do. Right here we have sine theta minus 1, set that equal to 0. Okay, so add 1 on both sides. Okay, so you end up with sine theta equals 1. Okay, so here is our next possible solution here. All right, so well, the nice thing about this is that we don't have that, right? It's just plain old theta, so we don't have any substitutions going on anywhere. So we need just 1 time around the circle. So we can just draw 1 circle here. All right. All right, so now again, which special right would give you a sine of 1/2? I'm guessing 30, because opposite of 30 is a 1, 2, and root 3. So opposite over hypotenuse is equal to 1/2 there. So 30 degrees. And not only that, but it is a positive 30 degrees. So sine is positive, like the y's. Sine is positive, everywhere where y is positive, which is first quadrant, always first quadrant, and second quadrant there. I'm also going to work this in radians just so you get used to it, right? So 30 degrees is the same as pi over 6. Okay, so we have a pi over 6 here and a pi over 6 there. Okay, so that takes around, right? If you're going around the circle from 0, that's one time around. You're never going to get another solution for sine equals positive 1/2. Okay, so those are those two right there. And then you have this one over here. Where, at what angle does the sine equal 1? Positive 1. Well, remember, sines are like y. 1 is the highest number on the unit circle. So it is the highest y here. So it's going to be right here at pi over 2. There's no other place, right? Sine is 0, goes down to negative numbers below this x-axis here. So this is it right here at 90 degrees or pi over 2. And what is this one? Pi over 6. That's the other one. So there's two answers, 1, 2 for when sine equals 1/2, and there's one answer for when sine equals 1. That is it. Okay, so we have this other one here that we need to write in from here to here. This terminal angle right here, that would be, this would be 6 pi over 6. Going backwards by pi over 6 gives you 5 pi over 6. And that's it. That's your solutions. You don't have, right, you're not dividing by 2. You don't have any of that algebra to do with it. On the theta is the theta here. It's not theta over 2 or 2 theta or theta plus 2 pi or something like that. It's just theta. So one time around the circle, these are all the possible solutions. If you don't believe it, try it with degrees. Try it with the degrees and then plunk the degrees in here and see what you get for an answer. Like 30 degrees, put in 30 degrees in here, 2 times the sine of 30 degrees squared minus 3 times the sine of 30 plus 1, and see if that equals 0. Okay, so here's your answer. Let's just do it nice and cleanly. Your possible solutions are pi over 6, or pi over 2, or 5 pi over 6. And there you go, a quadratic. So the main thing is to see an algebra connection going on here with all of these problems. Okay, thank you very much.